Alright, so let's move on to some simple arithmetic operations. So I've already demonstrated some operations already. For addition, we use the plus. Subtraction, we use minus. For multiplication, we use the asterisk. For division, we use forward slash. For what's the other one? Exponent. For the exponentiation, use the caret symbol. Okay, caret is shift 6. So let's give an example. So 3 plus 3 is addition. This is 6. 3 minus 3, 0. 3 minus 5 minus 14, negative 9. Right, so 5 times 8, 40, 50 divided by 10, 5. Right, so a note about division. 50 divided by 10, or let's say 10 divided by 2. 10 divided by 2, you can see that the slash leans towards the 2, meaning that this is 10 divided by 2, 10 over 2. Alright, so whatever the slash is leaning towards, that is what is the denominator. So take this other instance, 2 backward slash 10. Here the slash is leaning towards the 2. The backward slash is also used for division, but in this case this is also 10 over 2, just that the slash, you're using a backward slash, so the denominator will be on the left side. That's where the slash is leaning towards. So this is 10 over 2, and get the same answer, 5. So if you have to do 2 forward slash 10, this is now 2 over 10, which is 1 over 5, 0.2. If you had to use the backward slash now, this would be this 2 over 10. Right, but for safety, just stick with using the forward slash so that you don't get confused, unless you have a good reason to use the backward slash. Okay, so that's addition, multiplication, division, and subtraction. Next, the exponentiation. 3 raised to the power 2, this is 9. 3 times 3, 4 raised to the power 3, 64. That's 4 times 4 times 4. Okay, so 5 raised to the power 5, 625. Nope, 3125. Okay, my mistake. Right, 3125. So that's that. So let's take some more complex examples to solve. Okay, so here I have this 56 times the sum of two fractions in parentheses. So you add up the two fractions first before you multiply by 56. So 56 times 17 over 13 plus 27 over 38. So let's see how we would express that in MATLAB. So to clear your screen, you can use CLC, clear screen, and that erases everything in the command window. So let's write out our expression. So 56 times, so we open the parentheses and type 17 divided by 13 plus 27 divided by 38. I believe that is the 38 here. So you have to remember to close your parentheses, if not you'll get MATLAB will throw an error. So 56 times this will be evaluated, and the answer is 113.0202, and this is saved in the variable ANS, standing for answer. So if I type out ANS and call it, this will give me that value, 113.0202. Okay, now what would happen if I didn't close the parentheses properly? If I left it open, here I'll run into an error. MATLAB will identify it as an invalid expression when calling a function or indexing a variable. Use parentheses. So this was not properly closed, so MATLAB threw an error. Otherwise, check for mismatched delimiters. So it gives you a suggestion for what would be a correction of the code you just ran. So it says, did you mean this? So this is actually what we meant, and if you run this, you get the same answer. Alright, so let's try the second one. 4 raised to the power 3 times sum of two fractions again, 4 over 5 plus 7 over 3 times 8. Okay, so out here we have an exponent, and inside we have sum of two fractions, and the denominator of the second fraction is the product of two numbers, 4 over 5, 7 over 3 times 8. So let's do this. Okay, first we have 4 raised to the power of 3, right? So this now multiplied by 4 divided by 5 plus 7 divided by 3 times 8, right? So if you are good with your calculator, you will know that this will give you the wrong answer, because 7 divided by 3 times 8 is multiplying 7 over the fraction 7 over 3 by 8, not multiplying the denominator 3 here by 8. Okay, so what you do is you have to make sure that this is in parentheses. 3 multiplying 8 happens before 7 divides that value. So 3 times 8 has to be in parentheses. So this is the representation of that expression, and if you run this to give you the correct answer, 69.8667. So if you notice, the ANS has been updated from 113 to this value now. So the answer always updates to the most recent evaluation. Okay, so we could have stored this value in a variable like this, x equals this. So instead of it being stored in ans, it will be stored in x. And we can make reference to it whenever we want. X times answer, x plus ans. Okay, so x and answer are the same here. So let's move on to the next one. The next one, I made it a lot more complex. Here we have two variables within the expression, a and r, and they appear multiple times. So a here is a variable, r is a variable. Okay, so we have two brackets multiplying each other, 5a plus 6r, and in the second one, 17 over 13r plus 27 over 38r, and this second bracket is raised to the power 4. Okay, so what I'm going to do here is I am going to give a and r arbitrary values. So let's say a is 1 and r is also 1, right? A is 1 and r is also 1, and then we'll evaluate that. Let's put the answer in a variable called y for no reason. Actually, we don't even need that. Let's just forget it. So first of all, first bracket, 5a plus 6r, 5a plus 6r. So 5a is 5 times a plus 6r is 6 times r. So we would want to put this in parentheses, then times second bracket, 17, what was it, 17 divided by 13r, 13r. So how would we write 13r? It have to be 13 times r in parentheses, then plus 27 times a divided by 38 times r. Now this bracket is raised to the power of 4. Okay, so this is the representation of that expression now. 5a plus 6r, 5a plus 6r times this second bracket raised to the power of 4, 17 over 13r plus 27a over 36r. And in each case, you are multiplying the number by the variable. And this is 182.5011. Okay, so that's our answer. The next one. So next I just added examples of mathematical formulas. Area of a circle, volume of a circle, area of a cylinder, and then Ohm's law. So pi r squared. So in MATLAB, pi is one of the keywords that we should not use as a variable name, because pi here has an inbuilt value, which is 3.1416 approximately. So let's run that example. Area equals pi times r squared. Remember, r here is 1 for this case. So pi times r squared. This is the area of a circle. So if the radius of the circle is 1, then the area will be 3.1416 units squared. And the second one, the volume, 4 over 3 pi r cubed. So for a sphere of radius 1, 4 over 3 times pi times r cubed. The volume is 4.1888 units cubed. Then for a cylinder, radius r and length l. So if we were to start typing out this, oops, I made a mistake. This should be volume, not area. Volume, and it should be volume of the sphere. So that it would be sensible. And then area of the cylinder, 2 pi r l, nope, 2 pi r squared plus 2 pi r l. Now if I run this, it's going to give me an error. If you can guess why before I press the enter. Yeah, on the unrecognized function of variable l, so we have not given l a value, which is why this will give me an error. First you have to give l a value. So let's just say it is 2. Cylinder has length 2 units. So if we run this line now, we'll get a value. Area of cylinder 18.8496. Okay, so if there is no value assigned to any of your variables, MATLAB will throw an error. So each of your variables needs to have a value in order for it to be, for the expression to be evaluated. Because if there is no value for any of the variables, then the expression cannot be evaluated. Then lastly, I equals V over R. This is the famous Ohm's law. So current is equal to voltage divided by resistance. So let's give each of these a value. Current 5. Nope, not current 5. Current is what we're looking for. So voltage equals 5 and resistance equals 10. Current will be equal to voltage divided by resistance. This will be 0.5, which is the answer. Alright, so thank you very much, and I hope that this helps you understand a lot about variables, data types, and the mathematical expressions that you can carry out with MATLAB.